Hello everyone, this is our class number 17, Multiple Regression Model, Inference, Part 3. And actually this is the last part of Chapter 4. So in this chapter, in the previous lectures, we've talked about what is model inference, why we need to do some hypothesis testing, and how we construct confidence intervals, right? And we basically reviewed the motivation why we need to do these sort of things, because you're interested to answer some very interesting questions at the end of the day when it comes to your research. Okay, so if I go back to the whiteboard, so these are the things that we have covered so far. So the first, we have covered 5 different types of cases of hypothesis testing. The first one is a right tail test, the second one left tail test. The third and fourth one are two-tailed tests, but in the third one we look at when beta is equal to 0. In the fourth one we considered when beta was any number. We said basically equal to aj, right? And then we went ahead and looked at the linear combination of beta hat j, so we test that hypothesis as well. So we said if you want, for example, the example that we reviewed was if you wanted to see the effect of junior college and the university college on wage was exactly the same or not. So for those kind of things, we use linear combination of beta j's. And for all of these first 5 cases, if you noticed, we can use t-stat or the p-value, and especially for these two ones, for the number 3 and 4, we could use confidence intervals as well, right? We said that if that confidence interval contain the population parameter under the null, it's a bad thing, we fail to reject. If it does not contain, it's a good thing, we reject the null, right? So these are the things that we already covered. Now, in our class today, we're going to add 2 more cases. The first one is joint significant, and the second one is what we call overall significance, right? So the overall significance is basically the model significance, if we want to see if everything that we put in the model collectively makes sense or not. So these two are very, the way that we come up with the test statistics and the rejection rules are very, very much the same. So let's start with the 6th one and give you a big picture. And in the lecture videos, I'll open up the equations and talk about the motivation and the derivation of each these formulas, right? So number 6, our case number 6 is joint significance. So sometimes you're interested to test if some of our variables together are significant or not, right? So let's say I have 10 explanatory variables. I want to see if 2 of them, 3 of them, 5 of them together, collectively, jointly are significant or not, right? So basically we're doing something like this. Imagine this is my y variable, x1, x2, x3, and x4. Imagine I want to see if, for example, x1 and 2 collectively, if these two are significant or not, right? Out of the 4 ones. So for that, we have to go ahead and use the joint significance test. And our test statistic is not going to be t anymore. It's going to be f. Okay, we will talk about the derivation of this f, but when we have calculated the f statistic, we can use the f distribution here, and then the rejection area is going to be always the same if that statistic is large enough, greater than a critical value. We're going to talk about these things in the following videos, but that's basically the idea. Our p-value rule is going to be exactly the same. If p-value is less than alpha, is less than your significance level, we will go ahead and reject the null, right? So this was our case number 6, and finally case number 7, we do something that we call overall significance of the model. So basically you're saying that everything that you have in the model, look at that, look at our null hypothesis. Null hypothesis says that everything that you have in the model is significant or not collectively. Beta 1, beta 2, beta 3, beta, and up to beta k. So if I have 10 variables in the model, I want to see if all of them, all the 10 of them together are relevant or not. So we're doing something like this. So imagine this is my y, then x1, x2, x3, and x4. I want to see if this is the case, or maybe this is the case. I want to see if these 4s are collectively significant or not, right? And again, the formula is basically the same, but when it comes to overall significance, we can even reduce it to another formula, which is easier to work with. But the rejection rules and everything else is going to be exactly the same as case number 6. If your F statistic is larger than a critical value, good news. If your p-value is smaller than your significance level, good news, reject the null, right? In order to give you a heads up, most of the time we reject this null hypothesis very, very overwhelmingly. Because, guys, think about intuition. What is a null hypothesis? The null hypothesis for overall significance of the model is that everything that you put in the model, is relevant or not. So think about it. If let's say you're a researcher, you're doing a regression, and you're putting, I don't know, 10, 20 variables in the model, and if none of them are significant, then what you're doing here, right? So most of the time that we collectively, we overwhelmingly reject this idea that nothing is significant together. Okay. All right. So with that, I will see you in the next lecture. So this was a motivation or a big picture of what we're doing in this class, and see you in the next one.